Okay, we're now ready to connect power up and connect the oscilloscope up here. I'm going to highlight this again here. This might look slightly different than the one we had in the previous video. The components might be in slightly different holes, and that's because when I first attempted this video, I actually had some mistakes that I had made on the frequency settings, and basically I just made a disaster of a video. So I had tried to debug it, tear apart my circuit. So this is still the exact same circuit that was built in the previous video. It just might look slightly different because of where the placement of some of the resistors are, but there's nothing different about it. All right, so now we need to first figure out how to get positive and negative 15 volts in here. So I'm going to first turn this now to my power supply here and move some of these wires out of the way. And there's something very important here on how I've wired this up here. The first thing that might go against your thinking here is how you put the positive and negatives. Now, the BK Precision manual also shows you how to wire this, and they do it slightly different. They make this the -1. I like to make this one the positive, the fixed positive, and I make this one the -12. Now the key thing here is the fact that where you're putting your ground wires. This is something that's called like a floating ground, in the sense that these negatives aren't actually tied to earth ground. So, which is actually good for us because these negatives aren't actually tied to earth ground. That means we can actually tie them together to create both a positive and a negative voltage. So the key thing is, if you want it to be positive voltage, you put the ground on the negative side and you put the terminal that you're going to be supplying from on the positive. So this would be positive 12 because I've got my orange one coming into the positive, and then the gray one, which is my black, going into the negative. This one would be negative 12 because this is what I'm going to be feeding into the power supply. That's connected to the negative, and then I connect my ground to the positive side in order to make a negative voltage. Now, we can actually verify this by measuring using our DMM. I'll leave that to you to measure. We'll do a measurement with the oscilloscope once we get everything connected. So let's show how we're going to connect this in here. So we have my board here, and remember that all of this blue here is ground. So I can just connect these grounds into anywhere on that blue. So I'll just connect them both right there. And now I've got my yellow here. Well, my yellow is -12, and that's this one right here. So I need to connect my yellow one down into here. And then the orange one is, of course, my positive 12, which I need to connect up into here. And so again, regardless of the rest of your circuit that you're building, the op amp should be wired up like this. And in fact, if you're using plus or minus 12 volts to wire up your op amp, or even like plus or minus 15 or plus or minus 9, whatever, if you're using a positive and negative voltage on these op amps, this is always how you will wire up the power supplies. And that's critical because if you put the power in the wrong pins, if you put -12 on here, positive 12 on the other pin, you destroy the chip, and it's useless. So definitely be extra cautious and make sure that you follow exactly how I did with connecting the power supply up. Now, I'm not done wiring, but the one thing you should do as well beforehand, I had already done it, is I had already set this to positive 12 volts. But you should turn it on without anything connected. Not set it to, it's set at 12 volts, but this is actually, I'm sorry, the -12 volts here. But you should set this at 12 first, and you can always measure it using these terminals. Now, if you want to measure to see if this is -12, put your red cable of the DMM here, the black cable of the DMM here, because that's, again, ground, and this is your voltage line. So that would be the correct reading, and you can see that you'll get -12 from that. But we're not done wiring, so I'm going to turn the power supply off. Now, we do have the, here, let me just zoom back in here and kind of get some, we do have the signal generator connected in here. So we've got that connected into pin 3, which is the input, because this example, I was doing a non-inverting amplifier. Now we're going to connect up the oscilloscope probes here. Now, one thing that I encourage us to do, instead of sitting here, I was like, okay, well, I need to connect this to ground, so I could try and clip it onto this. We have plenty of wires. Use your wires. Well, I know that this side has to be connected to ground, so let's just pop another wire in here to ground, connect that to ground, and then I always want to measure both the input and the output of signals here, because we want to, when we're doing an amplifier, we want to see, well, is it amplifying? So I'm going to go ahead, and since I used a white wire there for the input, I'll use another white wire here. And you see I just attached it onto the clip here, as opposed to trying to, I could attach it right here, I suppose, if I wanted to. That's not awful. But I like to just go ahead and attach it directly in here and put the wire in. And then I can kind of put this off to the side here. Then I'm going to take my blue one, and again I'm going to put in a ground cable. So I'll put in a ground wire and connect this ground up here, just like so. And then I'm going to, well, I'll just go ahead and use blue, because this is a blue cable here. Doesn't really matter the colors, I just like to have some distinction. And then the output is on pin 1. Alright, so I'm going to go ahead and turn on my oscilloscope first. I like to turn that on first. And you're going to want to make sure that both channels are turned on. Okay, so both channels are turned on. And let's go ahead and clear my measurements off here, because I'm going to want to measure here. Because that's how we have to set this signal up for the correct frequency and amplitude here. So I'm going to go ahead and just put some measurements in here right away. I'm going to measure channel 1, the voltage. I want to measure the maximum voltage, because that will get me the amplitude, and that's supposed to be 1 volt. And, oops, I forgot to maximum. And then I'm also going to want to see that the frequency is the right frequency. If I had done this the first time, I would have noticed why my device was not working. So I'm going to go ahead and power up. And now I've powered up so I've turned on the power here. But now I also have to turn on the power to my signal generator, which is setting it to the correct frequency, which would be 1 kilohertz. And we can see I've got a 1 kilohertz signal here. Now yours might be all messy here, so you might have to do like an auto, do an auto set, do the multi-cycle here, and now you can see, okay, the frequency absolutely is correct. For some reason it took my voltage measurement away, so let's do voltage maximum, turn the menu off, and so I want that to be 1 volt, so I'm going to increase this here using the amplitude knob to 1 volt. Alright, so this is now we know that the yellow signal is the correct signal here. Now this is, whoops, just realized I'm doing a bunch of things here and you weren't able to see that. So let me just kind of quickly go through again what I was doing here. I was adjusting this knob here for the amplitude, so setting it, and you can see the amplitude measurement right there, and then you can adjust the positions of these. Now you see I'm adjusting position 2 here. If I hit channel 1, I'll adjust position of channel 1 here. So sometimes you want these to actually be overlapping. Sometimes you don't. Now the other key thing you want to point out right now is look at the scales. This is on a 1 volt scale for the yellow curve. This is on a 5 volt scale. So it looks like nothing's happened. It looks like they're the same signal. But they're really not, because they look like they're the same, but they're on 2 different scales. So let's just go ahead and go back to channel 2 here and change this scale to 1 volt. And if we change it to 1 volt, we can see actually, if I try and center it here, and then go back to channel 1, and so they're both at the same 0 here, we can see that, well, hey, this is definitely non-inverting, meaning that they're both going up and down at the same time, but we're definitely amplifying. Look at this blue curve. It's going, in fact, at 1 volt scale, I can't even see the entire blue curve. And And so that's of course why sometimes you want to have it on a different scale. So doing it on like a 2-volt scale. Now, it's still, you can say, oh, look, it's still showing amplification. Well, yeah, but you also have to remember this is 1 volt per division. So if we're going into this, the yellow curve, this would be 0, 1, 2, 3, 4. Now for the blue curve, this would be 0, 2, 4, 6. So there's definitely amplification going on here. One thing that can be useful is to actually display the measurements here for it. So I'm going to clear all my measurements off here, and I'm going to measure on channel 1 here. I'm going to measure a voltage, and I'm going to put what the peak-to-peak voltage is. So it's 2.12 volts. Then I'm going to switch to channel 2 and do a voltage and do a peak-to-peak. And now we can see that it's 9.84. So we can see what the amplification is going on here. Actually, I know it's a little fuzzy there. If you just divide those two numbers, you divide these two numbers, that's going to give you how much gain, how much are you amplifying it by. And then you can compare that to what the formula says you should be getting. Because our formula says you should be getting 1 plus 8.2 over 2.2, which doesn't, no, we're probably getting close to that. That's almost a gain of 5 there. Yeah, so we're getting close to that. So you can compare what the theoretical is telling you should get compared to what you're actually getting. Now, in the lab, you'll be doing an inverting amplifier. So what's going to happen is when you build your circuit, the yellow curve is still going to look like this. But then the blue curve is going to then first go down and then up, because everything that's positive is going to become negative, and everything that's negative is going to become positive because it's inverting. It's still going to look like a nice pretty sine wave, but it's not going to have the same thing here. Now, let me just show you one other thing here. Now, of course, you can take lots of different measurements. The more measurements you take, the better you can, justify it. For instance, what we can say is like, okay, well, let's not just look at the voltages here. Let's look at the time too. Let's look at the frequency of the output here, and look at channel 1's frequency as well. And turn the menu off, because they should be the same frequency. The frequency of the waveform shouldn't have changed, and you can visually see that the frequency hasn't changed, but then we've taken a measurement here, and we can see from the measurement that the frequency is still the same. Now, what I want to do here now to show you is I'm going to increase the amplitude of my input signal, and of course as I increase the amplitude, let me change the scale of my one here. As I increase the amplitude of my input signal, we can see that the amplitude of the output signal is increasing as well. And this is where it can get a little bit weird. When you're looking at it like this, it looks like you're not getting any gain, because remember your volt division here. This is at 5 volt scale, this is at 1 volt scale. So that's something you always have to keep in mind, is what are these scales at? Because when you put this at the 5 volt scale, it doesn't look like it looks like it's just tracking the signal, like there's no gain going on. But again, you need to look at, well, what is the scales on the different displays? That's critical. And then of course the measurements are always critical, because the measurements then tell you what the peak-to-peak voltages are. Now I'm going to do one small adjustment here on this to illustrate one other point here. So what I'm going to do is I'm going to turn my power supply off. I'm going to turn my signal generator off. And what I'm going to do here is I'll kind of show you here. So I'm going to take out this 2.2 kilo ohm resistor, and instead I'm going to put in a 1 kilo ohm resistor. And using my fat fingers to easy to pull things out, right? But then putting things back in can be a little bit more challenging. And that goes to ground. So I've changed the gain here, because now it's not 8.2 over 2.2, it'd be 8.2 over 1. So my gain's going to be 9.2. So I'm going to again turn it down a little bit, my amplitude. So I'm going to turn my signal back on, and so I can see my signal there. I'm going to turn my power supply back on. And let's see here. And let's do an auto. And let me pause here. I probably pulled a wire out somewhere, which is why I'm not getting anything now. You probably saw it right away. What I did is I actually didn't connect this to ground. I connected this to the negative 12. Okay, because that was the inverting terminal, but being very careful. That was a very critical mistake that I made, and it could have damaged both the chip and possibly some of the other equipment. But, you know, we're okay. And so let's go ahead and look back here. So I've put it in, it should be a gain of 8.2 now. So let's go ahead and put some measurements back on here. I'm going to clear them all. Voltage, let's do the peak to peak again. And then let's do the voltage of, channel 2 voltage, peak to peak. Okay. And so, yeah, we can see that we're getting about the proper gain. But I'm going to start turning the amplitude up here on this. And now notice here, I'm going to change my scale a tiny bit on these. Notice that my input's still a very nice, you know, sine wave, and I've got 4.64 peak to peak, 4.56. But then look at the output. The output looks really messy. It doesn't look like a sine wave at all. And we should think about this for a second. This should make sense for us because it says the peak to peak is 23.2 volts. And, well, what are we supplying this with? We're supplying this with positive 12 and negative 12 volts. So the absolute highest peak to peak we could get on an output would be a positive 12 volts on the output and a negative 12 volts on the output. So the absolute peak to peak would be 24 volts. And of course, we never will get 24 volts because this chip itself requires voltage to operate. So the reason we're only getting 23.2 on the output is because it's requiring 0.8 volts. This chip requires 0.8 volts to operate properly. But this is what's calling, and we've even talked about this in the course. This is what we're doing is we're saturating the op amp. You know, so we're basically, you know, cutting off this thing. So yes, it's still amplifying, but our the signal is basically too large as an input to have it so that we're not saturating. And then if I decrease this, we can see if I decrease slowly here, eventually I get to a point where I'm not saturating anymore. And that's because, again, the gain is something that would be okay. Because if I think about it going back to here, and if we just do 4.5 for say, and do a rough computation of the voltage being, you know, the output being 9, the gain being 9, well, peak to peak of 5 times 9 would be 45. So you need to be able to do peak to peak of 45 volts. We don't have plus or minus voltages to add up to 45 volts. We only have plus or minus to add up to 24, which is why in order to get the sine wave to come back out on the output, we have to decrease this. And then if I multiply that by 9, we can see that, okay, now we're starting to get to that 21 again, as far as if you look at the peak to peak on this compared to this and multiply it by your gain. So something that's important to kind of play with and understand as far as the operation of op amps. Now, another thing that's interesting to do here is to change the frequency here. So let's go ahead and put my thing back down to 1 volt here, and roughly, and then I'll auto set this again. Just multi, and so we still have the 505 volts. So we're getting roughly, oh, that's the divisions here. The measurements here, let's measure, and let's put the peak to peaks back on here. Actually, no, let's leave the frequencies on here. So let's do frequency of this one here. So we got 1.0 kilohertz. Now I'm going to increase these frequencies a little bit here. So I'm going to increase to 1.5, and we see, hey, it still looks the same. Nothing seems to be going wrong. Okay, well now what I'm going to do, I'm going to turn this off for a second and go times 100. And so now this is at 2 kilohertz, and I'm going to continue to increase the frequency. And so I'll adjust my time scale as I increase my frequency. And, you know, it seems like it's amplifying, but wait a minute. Look at the output now. You can see there's starting to be a tiny bit of a distortion here. You can see it even more. Now, let me adjust the time again. Now you can see this distortion even more going on here. And this is at 15 kilohertz here. And we're seeing, like, well, wait a minute. I'm not doing a good job amplifying at 15 kilohertz. And the reason is it's something called a gain bandwidth product that contributes to this, and also something that's called slew rate. So remember, these are real devices when we're putting these in. These don't follow the classical theoretical stuff. So this op amp, in essence, you can say just doesn't have enough bandwidth or is not fast enough to amplify this kind of signal. And you might say, well, this isn't even that high a frequency, which it's not, but this is a very inexpensive kind of cheap op amp that we use for classroom purposes. You can spend a lot more money getting op amps that can clearly amplify in this region with no problem. In fact, you have another chip that's an audio amplifier that can amplify in this region with no problem, because, you know, this is still in the audio frequency range. All right, so that's kind of hopefully giving you a little bit of understanding on, one, how to use this machine, how to wire things up for the lab, and take measurements. Now, I just want to remind you, for your lab, this circuit is not the correct circuit. Let's even jump online here. This is the power supply manual here. I'm going to jump online here and go into our course. Whoops, that's the oscilloscope manual, which, I mean, it's pretty dense, but it's also useful to read it at times. I mean, not the whole thing, obviously, but it's good to glance through it. This is the circuit we're building, which is different than the circuit we built in the videos here. So keep that in mind as well. All right? So hopefully you have success with this lab. It's really supposed to just be kind of an introduction to op amps and seeing how to wire them up.